Course 3, Lesson 97, we are looking at recursive rules for sequences. This is a way to take a previous term and add that constant difference or ratio and get to our next term. So let's look at some different things that we need to know for this. First, we need to define some of our variables. So n is the term that we have. Okay, if it's the first, second, third, fourth, and so on. N minus 1 is then the previous term, because if we said, all right, my n is, let's say, 3, well then my n minus 1 would be 3 minus 1. That is our second term. Okay, let me just get rid of some of those lines. Okay, A is our value, meaning that's the actual amount that we have for that first term, second term, whatever it is. And A sub n minus 1 is in the value of the previous term. A recursive formula is the value of any term expressed by referencing the previous term. We need to know what came before it to be able to find the next one. And it's only used to find the next term. It's not used to find any term given the position. So say we wanted the 100th term in a sequence. That means that I need to know the 99th, which means I need to know the 98th, 97th, 96th. We need to know what came before it to be able to find the next term. So we've talked about sequences before, and we have two ways to do it. All right, so if we had this sequence 4, 7, 10, 13, well, we have our nth term formula, which is something we've found before, and that finds a value for a specific term. For this one, in this case, the formula is a sub n equals 3n plus 1. So if I wanted the third term, which should give us 10, so if I did a sub 3, that would be 3 times 3 plus 1. So a sub 3 should be 9 plus 1, which is 10. So that's exactly what it gives us, and that is our third term of the sequence. Whereas a recursive formula tells us how to get to the next term. So if the first term is 4, to get to the very next term, we have to add the preceding term by 3. That's our pattern. We do 4 plus 3, 7 plus 3, 10 plus 3, and so on. So, to create a recursive formula, we have to have two things. We have to have a sub 1 is 4, so we have to say what term are we starting on, and we have to tell what the pattern is, saying that if I want a term a sub n, I have to do this to a sub n minus 1, and in this case I have to add 3 to the previous term. So let's try this out. If we have 3, 6, 9, 12, what is the rule for this sequence? Well, that's our nth term. Or what's the rule for the sequence? We add 3. Really all we're doing is adding 3 to each term. So what is the recursive formula? Well, remember we need two parts, and I'll write it up at the top of the page. We need our first term, which is 3. And then we need how to get from one term to the next. So we always say a sub n equals something to my a sub n minus 1. Something has to be done to my previous term, whether that's multiplying, adding, subtracting, dividing. In this case, we have to take 3 and add it to my previous term. So that would be our recursive sequence, or recursive formula for this sequence. Let's try it again. Let's try it on these ones. We have 2, 4, 8, 16, 32. Well, if we see, we have a pattern of times 2. We do it to everything times 2. So my a sub 1 is 2, and then we would say a sub n equals 2 times a sub n minus 1. And we could try this out. We could say, all right, if I wanted a sub 2, well, that means that I need to do 2 times a sub 2 minus 1. Should be a minus. And we have a sub 2 is equal to 2 times a sub 1, and we know that our a sub 1 is 2, which means I do 2 times 2, which is 4, which works out perfectly because that is my next term. And I could do a sub 3, which is 2 times a sub 3 minus 1, which means I need my 2 times my second term, a sub 2, which we found was 4, So we could say, well, that's just 2 times 4, which is 8, which is exactly what we have in our pattern. Next one, 1 over 54. Well, a sub 1, that's my first term, 1, and a sub n equals something has been done to a sub n minus 1. We can see that we multiply by 4 in everything, which means that we need to do 4 times a sub n minus 1. In more complicated ones, you might use this back blank to maybe add 3, minus 5, something like that. But in this case, we're just multiplying by 4. Let's try another one. We are given the formula a sub n equals 1 plus 2n. Well, this isn't a recursive formula, but we need to write one. So let's find the first 4 terms of the sequence so that we can say, what is our pattern between numbers? So we say a sub 1 is 1 plus 2 times 1, which means I get 2 plus 1, which is 3. A sub 2 is 1 plus 2 times 2, which is 5. A sub 3 is 7. A sub 4 is 9. Which means if I look at my pattern, 3, 5, 7, 9, I add 2 to each term before it. So my first term is 3, and then I say 2 plus my previous term. I add 2 to each term. A sub n equals 5n minus 2. So let's find the first 4 terms. A sub 1 is 5 times 1 minus 2, which means I get 3. A sub 2 is 5 times 2 minus 2, which is 8. A sub 3 means I get 15 minus 2, which is, 13. And a sub 4, we get 20 minus 2, which is 18. So my pattern, 3, 8, 13, 18, means that I add 5 to the previous term. And I always start my recursive formula saying a sub 1 is 3 in this case, and a sub n is 5 plus a sub n minus 1. We always do something to our previous term, a sub n minus 1. One of the terms in the sequence is 729. Write a recursive formula for the sequence and find the term that follows 729. Well, if we look at our pattern, we go 1 to 3, 3 to 9, 9 to 27. We are multiplying by 3, which means we can write my recursive formula, a sub 1 equals 1 in this case, and then a sub n equals 3 times a sub n minus 1, meaning if we have a previous term, we're going to multiply by 3 to get the next one. So if we have 729, I need to multiply by 3 to get to the next term. So we would get, 27, 6, 8, 21. We would get 2,187 as the next term that follows 729. We just use the pattern to continue it. Let's do a couple more examples. A recursive formula for the sequence is a sub 1 equals 5, and a sub n equals 3 times a sub n minus 1. Meaning all I need to do is say, well, every term that I had before, I need to multiply by 3. So if my first one is 5, then I need to multiply by 3 to get 15, multiply by 3 to get 45, and those are my second and third terms. And then lastly, let's look at this sequence and see which one of these formulas generates what we have up there. So, 2, 3, 5, 9, 17, 33. It doesn't look like there's a pattern to say, oh, I'm adding 1 every time. So in this case, if we start with 2 and add 1 every time, that's not going to work. Maybe it's one of these two. So let's plug in some numbers and say, what if we do a sub 4 with this one? That would mean we need to do 2 times 4 minus 1. And that means a sub 4 should be 7. Well, is a sub 4 7? No, it's not. Because we can see that our fourth term here is 9, so this one's not going to work. Let's try our last one, make sure it works. We say, okay, a sub 1 is 2. That works. A sub n is I multiply by 2 and then subtract 1. So let's find my a sub 2. We'd say 2 times a sub n minus 1. Well, that means I'm looking for the first term. Well, our first term is 2 minus 1. So 4 minus 1 is 3. Well, that works. A sub 3. We do 2 times my previous term, so that's 3 minus 1. So 6 minus 1 is 5. That works. Let's try one more time. A sub 4. 2 times 5, my previous term, minus 1 is 9. That works. So this is my formula for this sequence. Well, I hope this is helpful for studying and for your homework.